Can black hole cosmology explain why dark energy is changing? The BBC reported hints that the accelerated expansion of the observable universe could be slowing down. How might black hole cosmology explain this? Imagine that the Big Bang was actually an explosion inside a black hole, producing a shockwave that concentrates mass in a dense shell, somewhere beyond the limits of our observation. Because the volume inside the shell expands in 3 dimensions, while the shell, approximately, only expands in 2 dimensions, this means that the central volume's density lowers compared to the shell's. This relative underdensity in the centre, where our observable universe is, results in the acceleration. This is according to Einstein's theory of general relativity, without the need for dark energy. Of course, this is a speculative idea that would need evidence predictions to be considered as a serious challenge to the standard Big Bang model. However, the scientists who developed this shockwave cosmology inside a black hole do make a testable prediction. Here's how this model might explain this recent hint that the acceleration is lessening. If the outer shell decreases in density, which could happen in a number of ways, then that can reduce the acceleration. What might reduce the outer shell's density? It could be due to the shell expanding and stretching out, so it becomes less 2-dimensional and more 3-dimensional, so reducing the differences in density with the central volume. It could be that some matter might be pushed out by the shockwave. Also, the shockwave weakens over time, and then the formation of structure and galaxies from the matter that was in the shockwave can spread it out over time. This alternative to dark energy is just one of 7 reasons to consider black hole cosmology, and you can see all 7 in the 20-minute video.